All right, good afternoon, everyone. Hope you woke up from that elevator music. I want some upbeat techno, but they didn't go with that. Would have been awesome. Like, let's go. The party starts after this talk. All right, I'm happy to see that so many of you are still interested in what's new in .NET and C#, this never-ending changing language. There's so much happening in C# and .NET. And for the next hour, we're going to talk about all of the amazing ththings that was released in November and potentially what might be coming a little bit in the future as well. So my name is Filip Ekberg. I'm very happy to have been able to come here to Melbourne. I flew all the way from Sweden to talk about .NET and C#. So if you have any questions afterwards, feel free to send me an email and ask any questions. Funny thing is that I've always told people to send me emails at my talks, but for some reason, no one ever reached out. Turns out, I forgot to put my email on the slide. It's like emailing 101. So next time I came back, people were really upset. Now, all joking aside, send me an email if you have any questions afterwards, or grab me in the hallway. So I'd like to know how many of you are waiting for an LTS version of .NET before you update? That is almost half of you. Are all of you working with enterprise applications? Yeah? No? But still deciding to wait for an update. So funny thing is, every year Microsoft releases a version of .NET. In November last year, they released .NET 9. In November this year, they're going to release .NET 10. And in no way is LTS or STS a reflection to the quality of what's released. The only thing that it matters, if it's long-term support or short-term support, is for how long they will provide security updates and support for their enterprise customers. So there's really no reason for you not to update to the latest version of .NET unless you have a really lot of excessive testing that you have to do every time you release your product. Like, I get that some products have a lot of testing involved to get them released, but if you don't, and if you have to wait for every second year, there's going to be a little bit more of a headache to update. You're going to run into things that might have broken in the middle of those releases. So I would say that every November, just aim to update .NET and you'll be super happy. And I'm not saying that because I'm a consultant and do this for a living. It's a part of the reason, though. But it actually does make my life a lot easier if my clients or myself update to the latest version of .NET, because then I don't really run into a lot of issues. So we're going to be focusing, though, on what's new in .NET 9 that was released in November. So if you've updated Visual Studio, if you've got the Visual Studio Preview, if you've got VS Code with the latest C# dev extensions, you've got access to all of what's available in .NET and C#. So if we first start talking about what .NET is really all about, it contains a whole lot of different things. It's not just a framework or a part of the runtime or the language. It's a lot of different things that's included in what actually .NET and a release of .NET is. A huge part of this is working on stability. So every version of .NET comes with a lot of stability improvements. That involves everything around how stable the runtime is, how stable things are when you compile your application, and how Visual Studio works, and all the analyzers. So when you update .NET, it includes a whole lot of different things. And stability is really one of the important pillars in that update. There's also a lot of focus on performance. And I'm probably going to say this quite a lot of times throughout this talk, that performance has been a huge part of .NET ever since the early days of .NET Core and .NET 5, 6, 7, and 8. They've done improvements to performance to all the types available in .NET and how they use those performance-focused types themselves when they build their APIs. I have a couple of examples of that later on, of how you can use memory efficiency to write much better and faster code. All right, so .NET 9 also helps us with productivity in terms of analyzers and Visual Studio updates and everything around how that would work as well. Also, I guess one of the important things with .NET is to focus on security. There's some breaking changes in .NET 9 in terms of how ASP.NET Core works with OpenID Connect and OAuth. So if you're just updating to the latest version of .NET, you're going to get that for free out of the box, which is a more secure approach of doing authentication and authorization. I have a slide on that later on as well. There's also web improvements in terms of Blazor, ASP.NET Core, working with Azure Functions, and all of that, as well as the tooling support in Visual Studio. We've got mobile support. Who's doing MAUI? One person? That's 100% more than last time I asked. I'm kidding. MAUI is actually getting to a really great spot. I've done Xamarin for a long time, which was the predecessor to Maui. And nowadays, the tooling is a lot better than it used to be, and it's actually pleasant to work with. So I'd suggest that if you're looking at building a mobile application, or at least a hybrid application, I would suggest looking into that as well. And of course, last but not least, we have all the updates to C# as a language and how you work with that, and the additions to how and what you can do in C#. I'm going to cover a little bit about that as well. So as you see here, there's quite a lot of stuff that's released every time .NET is released. There's so many teams working on different portions of this, so it can be a little bit tricky to keep up, which is why I'm here, to talk about how we can build anything, on anything. We can build on Macs, on PCs, and we can deploy this to anywhere. As long as we deploy to Azure, Microsoft's going to be very happy. I mean, that's the end goal, though. Like, if you don't publish to Azure, like, there's no point. All right, so if you want to use the latest version of .NET or use a specific version of C# together with .NET, like this list here shows you which version goes with which version of C# and .NET, and that can be a little bit tricky to understand. Like, I don't know how many of you are talking in terms of which version of C# you're using, because often it doesn't matter because, again, we should always update. But if you go back to an earlier version of a project or you work in something where you need to work in .NET Framework or a legacy project, that might be a little bit more interesting. But if you were to happen to go into a project that either uses .NET Core 3.0 or .NET Framework or some other non-supported version, you can still actually use a couple of the things from C# 13 and 14 if you'd like to, by tricking the CS prod file to use the latest version of the compiler, which is unsupported, but at least it gives you a little bit more of a pleasant experience with when working with at least the language portions of the things. All right, so with that being said, we're going to be focusing on .NET 9 and C# 13. And what I like to focus specifically on in .NET 9 is a little bit of the performance improvements. I'm going to show a couple of things that might be interesting to you. You can work with spans, and you can work with the new extensions to working with spans and so forth to write really high performance code. But under the surface, there's a lot more happening internally. So they've actually done a lot of work on the compiler and the runtime to make everything more performant. So just by recompiling the application, you'll get performance improvements out of the box. As an example, there's a feature called induction variable widening. So when you compile a 64-bit application, instead of having to cast an integer inside a for loop to 32-bit or 64-bit, do that each time in each iteration, it will be much more performant and avoid that casting by implementing this feature in the compiler. So by just recompiling the application for high-performance applications targeting 64-bit processes, the application will just by default be a lot faster. And there's a lot more. Like, that's a very specific case, right? But there's a lot more things happening as well. There's also a lot of changes to System.Text.Json. And I'd like to know how many of you are still using Newtonsoft.json or JSON.NET? Oh, wow. That's kind of half of you. That's amazing. It's time to update. Now, the funny thing is System.Text.Json was never supposed to just replace JSON.NET, even though they hired the guy. The idea is just to have a real high performance. Again, I'm going to talk a lot about performance, but it's a performant alternative that if you own both sides of the producer and the consumer and using System.Text.Json, you'll end up having a really high performance JSON serializer and deserializer. There's also a concept called feature switching. There's updates to time span. There's debugging improvements. There's, how many of you have heard about the binary formatter and used that? Oh my God, so many more than I would have hoped. It's now deprecated. It's turned off by using that feature switch language feature. So you can enable it if you really have to, and there's an update path to get rid of it completely if you need to, because it's considered a security risk to use it. If you've never heard about it, don't read up on it. Just ignore it. And there's, of course, a lot more happening as well. So let's jump over to Visual Studio and take a look at a few things. All right, so I'm going to start quite easy. I've got a couple of different projects targeting .NET 9 and using some of the functionality that gets out of the box. So the idea with .NET is to give us features that we use regularly and to avoid us having to write too much code and still do that securely and do it in an efficient manner. And one of those things that people tend to do a lot is base 64 URL encode things. So for example, here I'm using a type called read-only span of a byte, using a byte because I'm a hacker. And then I have this UTF-8 string literal, so I can still use it as a string in my application, but instead of being 16 bits, it's now 8 bytes, sorry. It's not being 16 bytes, it's 8 bytes. Anyways, I'd like to base64 URL encode this. Traditionally, we'd use convert to base64 string, but that's not URL encoded, so we'd have to remove things like a slash. We have to remove a lot of other stuff as well. And every time you do replace, that has to do a copy of that memory, which is really inefficient. It has to take the string, copy it over to somewhere else, and replace those characters, because we can't update a string in place. Instead, there's now this thing called base64 URL that lets you encode a string of data. And this actually accepts a read-only span. And a read-only span is a data structure that allows you to point to any arbitrary memory. So that can be memory that's managed, unmanaged, memory on the stack. And you can use this just like, sort of like an array, but it's a very much more memory efficient way. Think of it as using pointers in C++. So it's very memory efficient. There's some gotchas to where you can't and cannot use it. But in this case here, this method called encode to string accepts one of these really memory efficient types, and it does all of this in place, and it's really efficient. So instead of having to allocate a completely extra for every replace, it just does this quite efficiently. So if you ever do base64 encoding, this is a really great addition. It's a tiny thing, but still, it's quite interesting. Next up, speaking of these performance-focused types, and if we were going to work with the spans nowadays, like everything could be a span if we're working in a situation where it's appropriate. If you're using an asynchronous method, you cannot use spans. You can use memory instead. It's a little bit different, but I'm going to let you read up on that on your own. In this case here, you can see that I have a dictionary of a string and a string, which is just a cache of elements, for example. And now I'd like to access an element using, of course, a string, but if you didn't know, you can actually implicitly convert a string like I'm doing in this case here and assign that to a read-only span of a character. Because that's exactly what it is. It's a read-only place in memory of characters. It's an array of characters, but it's read-only. So why not use this performance-focused type that allows us to work very efficiently with that array of data? However, if I try to use this, I can implicitly convert the string to a read-only span. Would it then be able to do the same thing on the other way around? The problem is that I can't. I can't use that as the indexer for my cache here, because they're not the same type. And they've fixed this or added some support for this. So instead, I can create a lookup to say like, hey, I'd like to take my dictionary, which I call cache, and give me an alternative way of looking up elements. And I can now say, you're going to use a read-only span of a character as the key, and I can then use my lookup to actually access the element in the cache. So this is a little bit more of a interesting situation if you end up working with spans. And we should probably try to do that in as many cases as we can, just the same way that we should favor value tasks over tasks to avoid extra allocations. And all of these different things also enable the .NET team and everyone inside at Microsoft to add more performance-focused implementations internally as well. So again, by updating to .NET, they've applied these patterns and practices themselves and to make it more performant. I'd also like to talk about the feature switches. Now, who's using feature switches? Oh, just 2 people. All right. Feature switches is traditionally a way for you to turn on or turn off features in an application, be that in runtime or during compile time. These 2 different concepts or these 2 different ways of doing feature switching can have different implications of an application. Now, I'm not going to show you the CSproj file yet, and this language feature, or feature also, it's a language feature as well as a feature in .NET. It requires some specific things in the CSproj as well as in our code. So imagine that I have my application here and I'd like to turn off a feature when I publish this to a customer. Like we could use app switches or app configuration in Azure again to enable or disable things in runtime. But how about I'd like to remove things before they're actually sent off to my client for them to use the application. I don't want my code available that's experimental. So what I can do is that I can define a property called, in this case, isCreateFeatureEnabled. I'm going to decorate this with an attribute to say that I have a feature switch definition. And this here is called isCreateFeatureEnabled. So these have the same name just to make it a little bit easier. And this is a reflection of what I also have in my CS_proj file. There's no specific syntax that we have to write in some specific naming, but basically isCreateFeatureEnabled. I'm going to set this to false. And also have this magic thing called trim is equal to true. What this does is that in every place where I use this to check if the feature is enabled or not, when I compile my application, it will actually remove this from the compiled binary if I'm using AOT and trimming, which is quite nice, because that means I can publish my application to a customer, and they don't have my experimental code in it at all. It's quite good. It's a little bit different than having feature switches and A/B testing when we are actually live. But this here is good if you want to turn on or off features. You could do this in the build pipeline, for example.
How does that align with just conditional compilation items?
How does that align with conditional compilation items? It's the same thing. Yeah.
Much nicer syntax.
This, yeah? Yeah, because it just figures it out. Everywhere you use this Boolean, so like, hey, is this feature enabled? It just removes that. But I shouldn't say anything because I have regions everywhere, so my code looks nasty anyways. Like, could have just used that. All right, so a little bit more fun and probably something that people will use a little bit more is the improvements to System.Text.Json. And the first easy one is just they've added support for indentation characters. So now we can fight over tabs and spaces again, finally. Funny thing, though, like I can choose tabs or spaces, but I can't choose anything else. If I do an @ here, like it's going to give me a runtime error. Totally annoying. But I can do tabs and spaces. So I can dictate how much I want. This is just an addition to how we work with JSON, basically. There's also now a helper to allow us to have this default for how ASP.NET Core defaults when it deserializes or serializes JSON. So we can say JSON serializer options.web instead of having to create a new serializer option and setting the casing and setting all of those different things that we had to do earlier. So these different things and these additions to System.Text.Json just lets us more easily work with this in our applications. It's not, again, meant to be a fully fledged JSON.NET, but they do add things that some people actually miss when working with this. There's also a thing called OpenAPI, and we can export a schema for an entire type or an entire class, which is something that's used by OpenAPI and the additions to ASP.NET Core to provide a definition of your API. So I'm going to come back to this later on, but they've deprecated the swashbuckle ASP.NET Core package and not using that anymore in the template. The project is still live on GitHub, but it's not. Let's get back to that later. But anyways, the OpenAPI implementation uses this internally, and you could do this as well to generate documentation around your code. And when you run this here, it will give you all the information about the type. In this case, we can say, I'm going to export a JSON schema for this particular node, which would be my user class. It would look at all the properties. Are they read-only? What are the types? Everything that you need to know to get a specification for your types in your application. It's good to know that this exists, but you're probably not going to use it a lot. What you will use, though, is if you're using nullable reference types in C# or you're getting data passed into your application, it can be good to know how to turn on and turn off how System.Text.Json behaves when it gets that information. So we can turn on something called respect nullable. So if I'm creating some JSON serializer options, I can say I'd like to respect the nullable annotations. When I set that to true, that means that it's going to look at if we've annotated our class to be nullable or non-nullable. Meaning, if we take a look at this user class, last name is allowed to be an optional value, so I can set this to null if I'd like to. But first name is required. It has to be a value, cannot be null. So therefore, the JSON serializer, with that setting turned on, will enforce that we have actually set this to a value, which is good. You probably want that. And we also can also respect the constructor. There's a lot of respect going on in .NET 9. So we have this thing here, respect required constructor parameters, which will then look at the constructor of your class. So if we have, again, this record here, it will try to respect all of that and not use the default values. We can choose to make them optional or not, or set them to the default values. So again, they're doing some changes to System.Text.Json. Some of them are are better than others. The constructor parameters and the nullable respect is probably the better ones to know about if you want to turn on or turn off that based on what you're getting in your application, what type of data you're receiving. And now, speaking more about performance, there's some improvements to the APIs in terms of working with spans. As an example of that, we have file helpers. So you all probably know about file.writeAllText or readAllText. Previously, they didn't support passing in spans to them. And that was a little bit problematic because if you had a span of data coming into a method and you'd want to write that to a text file, you'd had to copy it over and like do toString, which is then, you could probably write this a little bit more efficiently, but you'd have to convert that into a string, which meant extra allocations. Being able to pass the actual span instead, which is, again, a way for you to just point to some arbitrary memory, it could more efficiently work with that data to write that to disk. And this is true for all the different file helpers and methods that work with spans and accept spans as input parameters. There's also an introduction of extension methods. So if I have, let's again go back here, I have my text here that says, hello, how are you doing? And I'd like to check, is this starting with hello? What this will do is that it will implicitly convert this to a span, hopefully. It will implicitly convert that to a read-only span of a character because that's the most appropriate type to use here. And I can now use starts with, ends with all my spans as well, which I was not able to do before. I can even set the comparer that I'd like to use, in this case, ordinal ignore case, which is the most performant way of comparing strings. And this isn't true only for strings. I have again, being a hacker, I have a byte array here with hexadecimal numbers. And I can say, hey, does this end with a given pattern? It doesn't have to be one. It could be multiple different ones as well. So this addition is really good for when we're working with spans, which we are probably all going to see a lot more of going forward. Now, the last one I want to show you is something to do with how we split data. So I have this input, which is a string. And I said this earlier as well, that we can just implicitly convert any string into a read-only span of a character. So what I do here is that I take my families, all my family here, and I'm going to implicitly convert that into a read-only span of characters. What that will allow me to do is that I can now call split like I could with a string. But if you do split on a string, what happens is that it's going to allocate a lot of extra memory. It's going to produce an array of all the different split elements. When you do split on a span, it produces what's called a span split enumerator. To make this less confusing, let's just do var. And what we get here is I get a set of ranges. So it will find the starting and the end position of this. It will find the starting and end position of this. And I can iterate through those different ranges and split by that. So why would I want to do this? Well, let's iterate through each range. And I can say, hey, I'd like to slice off that particular range. So what this will do is that first, it will give me Filip, next time Sophie, next time Mila, next time Elise. And it's doing this without performing any extra allocations. Like if we don't count this variable here and we don't count this variable here, there's a couple of allocations. I know someone's going to tell me, like, there's a couple of allocations. But we're not allocating strings. We're not copying any memory over. We're not doing any extensive operations here that could be actually seen in any benchmarking whatsoever. The first time I'm actually doing any allocations is when I'm calling toString. We're actually copying this over. So this here is a very memory efficient way of scanning through some text of data. I could be reading one line at a time from a disk, getting a read-only span of character off that line, and scanning through what I'm looking for. Fun fact, I've used this to replace some really slow regexes to ensure that I can process some text a lot faster. And replacing a regex is always a great idea because they are impossible to understand what they do. With Copilot or ChatGPT or whatever, it's easier, but they're still really terrible to maintain and read. So being able to do this instead and write a little bit of code to slice off data or look for something, create a lookup, it's quite nice. All right, finally, the final thing I want to talk about in .NET 9, one of the most important updates is to time span. Someone reported a bug that when you do time span from seconds, 64.823, there's a rounding error. If I run this, this is actually not 64.823. It's actually 822999999. Whoever ran into this and reported this as a bug is a superhero. Funny. So that made them add an overload. So you can now do 64, and then you add the milliseconds after it, so you can supply all the different portions. I'm kidding, though. This is not the most important feature, if that wasn't obvious. But it is good, though. All right. So with that being said, let's take a look. Where are we at? In terms of security, how many of you are using OpenID Connect, OAuth? Yeah? That's quite a lot, but 2 handfuls. So they're changing how this works in .NET, ASP.NET Core 9. Here's the previous state, here's a new state, and let's just go through it quite quickly. So what happens here is that we have our browser, we're going to navigate to a private website that will redirect us to the IDP, and it will ask for a response type. It will send some information about the scopes that you're requesting, about the client ID, and a lot of different things. The problem here is that this redirect is all the information is in the URL. It's unencrypted. You could potentially change this information and say, like, hey, I'm admin. Change my scope to super user or whatever. Like, you shouldn't be able to do that. That would be really terrible design anyways. But people tend to use scopes incorrectly when implementing OpenID Connect anyways. So therefore, there's this new thing called a pushed authorization request, that where automatically, if you have OpenID Connect to the middleware in ASP.NET Core, it will now do this instead, as long as the IDP supports it. There's an extra call over here that first sends a post request over to the identity server, and you get a request URI back. And then it redirects you over to the IDP with that information. So there's quite a bit of interesting additions here. And this is a much more secure approach, because now we're not leaking any information to the browser. The browser can't change anything. All they're getting is kind of an ID of your request. The IDP can then validate this and do that appropriately. All right. So that's one of the changes to ASP.NET Core 9. A couple of other things that they're doing in ASP.NET Core 9 is that they're doing some OpenAPI improvements. Improvements is kind of an understatement, because what they did was completely remove swashbuckle ASP.NET Core. Because the package wasn't updated often enough, it's open source, but it felt like it's not really updating at the same pace as .NET is. So instead of contributing to the project, they built their own. Good idea, I guess. So now OpenAPI is included in .NET 9 or ASP.NET Core, and you can use other things to, if you want to UI. It's still compatible, like Swagger UI and Swagger is still OpenAPI, and that specification is still the same thing. But you have to use something other than swashbuckle. It's not built in by default. There's signal or trimming and native AT improvements if you like that. There's a typed error called internal server error. I'm going to show you that in just a moment. There's the improvements to authorization and authentication. There's a hybrid cache added, and they've added middleware and keyed DI support, and a little bit more of things. Let's jump over to Visual Studio again. It's more fun than spending time in PowerPoint. So in terms of some changes to ASP.NET, we have this thing called map static assets. Map static assets is an evolution of mapping static files in ASP.NET. So instead of using that normal traditional map static files, which would just point to a file on disk, this thing will in fact ensure that it's compressed. It does gzip and deflate. It will send an E tag to the browser so that it knows that it can cache this appropriately. It will do a lot of things for you, which is quite great. And in terms of security, I have a controller here where I'm inheriting from a base controller, and for some reason I'm getting a little bit of a squiggly here, because what I'm doing here is that inside my controller, inside ASP.NET, I'd like to say, hey, I'd like to ensure that you have to authorize to access this endpoint. But for some reason I'm getting a squiggly here that's telling me this is overridden by someone else. So you're actually not going to be required to be authorized. what happens is that the base controller has allow anonymous on it. And I don't know how many times this has bit me that I have allow anonymous on a controller, I inherit from that, and then it doesn't force me to log in. Because what happens here is allow anonymous overrides any other attribute after it, depending on how you configure this. But by default, it's like this. So what they added in .NET 9 is this analyzer that's telling us that, hey, you have an authorized attribute. It's overridden by someone else. So you should probably go ahead and remove the allow anonymous from the base class. So adding analyzers like this here, and now I can't exit my Zoom. There we go. Whew. Scary. All right. And there's a couple of minimal API improvements as well. So again, OpenAPI is now built in by default, exposed at /OpenAPI, in this case, /v1.json, by just doing add OpenAPI. So that will give you a Swagger compatible specification because it's the same thing. You just have to add your own UI on top of that if you'd like to. And here's also an interesting addition to ASP.NET Core. There's this thing called typed results, which have always, or since they introduced this, so you want to use type results because then your Swagger documentation or OpenAPI specification can tell us that this could potentially give you a bad request. This could potentially give us an OK of a string or OK of a user, or it can give us an internal server error. I don't know who thinks it's a good idea to expose internal server error to the outside world. Like, I quite happily liked it when this was not available at all. I get it for some internal APIs, it would be potentially a good idea, but like if you capture an error and you return internal server error, like you should probably handle that instead of just passing on. Anyways, there's some improved debugging experiences as well, but most importantly with .NET 9, and this is still, I believe this is going to be fully released with .NET 10. It's still a preview feature, but there's this concept called a hybrid cache. Hybrid caching means that we're going to combine two different concepts of caching. There's memory caching, which is super fast. You want to store something in memory for a little time or for a long period of time. As long as the server is running, that's going to be available in your in-memory cache. The problem with memory caching is that it doesn't scale. If the application terminates, the cache is cleared. If the machine turns off, the cache is cleared as well. So to solve that, you can introduce a distributed cache like Redis, where you can store something in a cache that lives on a different system, some super fast machine that you just send off a key value pair to, and that's going to be cached in its very fast database. The problem with that is that you have latency. So the hybrid caching model means that we first store something in memory and also store it in the remote distributed cache, which could be Redis, for example. All right, so all that I have to do is that instead of either using, let's see here, instead of using the iDistributed cache or using a normal in-memory cache or iMemory cache, I can use a new type called hybrid cache, which will do all of this for me. It will store data in the memory cache. It will attempt to get something from the distributed cache if it's not available in the memory cache. If you turn off the distributed cache, it will attempt to load it from the memory, and if that doesn't work, well, then you're out of luck. It's not perfect. But what we do is that we introduce a hybrid cache. There's a couple of things we have to add to the solution to make that work. If you simply do add hybrid cache to the application, it will use the memory cache. If we also register, for example, a Redis cache, it will use that by default. As soon as we introduce an iDistributed cache to the dependency injection, the hybrid cache will use that. So if we take a look at this, it's super simple. I can say, hey, I'd like to get or create an element inside my hybrid cache based off this cache key. If that's available, fine, just return that to whoever. It doesn't matter if it's available in the memory cache or the distributed cache, it will attempt to get the one that's the quickest. And you can also have different expiries. So your memory cache could have a shorter expiry, and then it can go ahead and fetch it from the distributed cache if it so likes to. This is good for redundancy and so forth, and for really bigger applications. Because then we don't have to retrieve that potentially expensive data, unless we really have to. All right. So there's a lot of smaller things added as well to ASP.NET Core. But I guess a couple of important things is the map static assets is really great because then it allows us to use this concept of e-tagging and caching in the browser and delivering this really efficiently to the browser. And I'd really encourage you to take a look at the hybrid cache. It's super easy to just replace the distributed cache with this. The API is similar and works really well. Now, another really big thing, and you might have heard this, unless you've been living under a rock for a while. Anyone heard of Aspire? I want to point any fingers to someone that hasn't heard about it. .NET Aspire is a really great new tool from Microsoft. So what it does is that it allows us to create an orchestration of our different applications. Like we can point to different parts of our system, get a nice dashboard of what this looks like, be able to debug the applications by just starting one of our applications and get telemetry data. We can get logging for all of them at the same place. So instead of me just talking about exactly what this is doing, I'm going to quickly show you an example of what a solution could look like. Don't worry, these passwords are all fake anyway, so don't try to steal them. So I created this application, sort of just file new and then .NET Aspire starter project, and it gives me a couple of things. First of all, it gives me an ASP.NET Core minimal API called API Service. This is just a super simple application that returns some weather data. Think of this as any API in your project, a minimal API. And then we also, most of the times, we have a front end. In this case, it's Blazor. Could have been React, could have been a JavaScript front end, could have been whatever. It doesn't really matter. Now, to be able to start both of them and debug them at the same time and get information about how they communicate with each other, I'm going to create a couple of default behaviors for them in a separate project called Service Defaults. So this here simply introduces an extension that configures telemetry, health checks. It talks about how to set up the HTTP client resiliency. Now, both my API as well as my web frontend will both use these behaviors. It will use this file so that they can discover each other, for example, and so forth. So this is just like an opinionated way of configuring an ASP.NET Core application. You don't have to do this. Where the magic happens is in this project called app host. I'm going to click into my program.cs, and what happens here is that I'm going to define that I'm creating a distributed application. Let's say that this is going to be published in a famous cloud later on. And then what I'm going to do is that I'm going to say, hey, I'm going to use SQL Server. I'd like to use it on this specific port. Then I have a custom Docker container that I'd also like to use, which is in this case, it's the Azure Service Bus emulator. So I don't want to set up an Azure Service Bus for my development locally, because that's super expensive. I tried that once, and it was very expensive. So I would not recommend that. As long as you remember to turn it off, then it doesn't become expensive. So therefore, they now have this local emulator that you can run in Docker. So that's what I'm doing here. I'm pointing to a container. Then I'm also pointing to a Redis cache, saying, hey, I'd like to have support for a Redis distributed cache. I'm also going to have an API service, which is my MVC or my ASP.NET Core minimal API. I have a web frontend. The web frontend will have a reference to the API. It will have a reference to my cache. It will have a reference to SQL Server and a reference to my service bus. So the idea here now is that I'm going to press F5, and this here will be in charge of setting up SQL Server, setting up my Azure Service Bus emulator, starting my API, starting my web frontend. I can debug all of it through the same place. Now, running this in parallel on a Mac works sometimes not very good. So I started this through the command line instead, just did .NET run with this Aspire project. What happens is that it brings up this dashboard, which shows me a cache. I also got Redis Insights, which is a way for me to explore everything that's inside Redis. I have my Service Bus emulator. I have SQL Server. I have an API. I have my web frontend. If I open my web frontend, I can navigate through this here. This here actually communicates with my API that's running also through this app host, which is .NET, which .NET Aspire takes care of. So one interesting thing here, I can do a lot of things. I can go ahead and check the logs for each different application. You can see that I have an exception here that I should probably attend to. I can see structured logs and see exactly what happened here, if I'd like to, when this occurred. I can do traces to see how someone communicates with different parts of my system, how long things take. There's a lot that I can do with this. You don't have to do file new project to get this added to an existing solution. All you have to do is create that app host, point to your different projects, make sure the ports are all configured correctly. It's a quite easy process. I know a consultant that knows how to do this. I'm just kidding. There's a lot of good information on how to do this, and it's super easy to get set up. And once you get this set up, and even if you have a really complex system, getting new developers on board, just having them press F5 is super nice. Like, I don't know how many projects I've been in where it's like you have this 15 pages Confluence information. Like, you have to start this project first, start another instance of Visual Studio, and start on this port. You have to configure this and that, and it's like, no. This is just much easier.
So these are all emulated, am I right? They are not real resources.
It's running on your machine. So some of these things, that's a very good question. You're asking if it's all emulated. So for the SQL Server, that's running in Docker. For my normal applications, like the API service and the web frontend, that's just running like they would with .NET Run. And .NET Aspire takes care of all of that for you. So it runs, you can think of it like containerized if you'd like to. Like, it runs in its own little box. I do think I may actually have Docker here, so we can check Docker Desktop and see all my containers running here as well. And if I'd like to, I could go over here as well and do resources and say, like, hey, I'd like to stop my cache now. I can stop my API service and see how my different things would work. And it should be reflected here. Now, some things not working, but let's just imagine that this worked. But yeah, you can control all of it through here. You can add custom commands to do a lot of different things here as well. But the good thing here is that it kind of reduces the threshold to get new people on board. You get all the logging in the same place. You can debug multiple different instances of your applications or different parts of the system. It took a little while to stop, but now it's saying that it's not running anymore or unhealthy. You also have health checks and information about how all they're doing. You can write really complex things in here as well. And the good thing is that it has support for any Docker image, basically. So you can pull down anything and run whatever you want. And of course, that's a local development story. If we want to get this published somewhere, you can publish this. I think they're working on Kubernetes or K8 support to get this. You just press a button and just automatically creates the configuration for it to be deployed on premise. There's already support for getting this up in Azure. It's a super simple command, like setup, and it just creates everything in Azure. It also creates a README where it says cost. You should read about the cost implications of running this command and getting everything set up. I can tell you, running Redis, SQL Server, and the Azure Service Bus on the highest levels gets quite expensive. So always make sure that you check if it automatically creates something. Ensure that you know exactly what it's doing, right? All right, so specifically to .NET Aspire is not really a part of the traditional .NET 9 release. It was actually released not at the same time, and they've done improvements since. Aspire 10 is, for example, just a few weeks away. I think they were aiming for February, but maybe it's February somewhere else, not here yet. They added support for persistent containers in .NET 9 with the latest version of .NET Aspire, which means that when you press F5, you can have it configured so that it doesn't have to recreate SQL Server every time, which might take a little bit of time. And this here, being able to say that this container is persistent, is a lot more easier on your application. There's custom commands, there's health checks, there's a whole lot of different things as well. There's support for Azure Functions if you want that as well. And overall, like, a great experience. If you've ever seen this before, like, they add more and more support every day. There's, of course, also Blazor changes in .NET 9. Like, Blazor has been completely revamped over the past few versions. How it renders an application, where it runs, and how it communicates. It's getting better as well. Is anyone using Blazor? All right, handful, yeah. I would strongly suggest the rest of you to also check it out. It's actually a really good tool for full stack development, especially since they did all the changes. And same goes for .NET MAUI. Like, there's a lot of changes going on here as well in terms of performance and productivity and support for APIs and support for different native platforms. So last but not least, I'd like to talk a little bit about C# 13. There's not a whole lot in C# 13 in comparison to the other versions of C# that you might have seen in the past. Like, if we just look at all the really great language features that have been released over the past decades, like there's so much like switch expressions, asynchronous programming in streams, and like generics. There's a lot in C# that's been released over the past years. Like, we are not going to be able to go through all of this. And unfortunately, there's not as many cool things in C# 13. But there's still a couple of things that I really like to talk about. And C# is constantly being updated. And for me, a person that keeps trying to encourage people to update, like, I get happy that it's not a lot of overwhelming features each version of C#, because people get upset that, like, hey, do I need to rewrite my entire application again? And this is not feeling like C# 1 anymore, which I guess is a good thing. There's this new thing called a field keyword, which is in preview for C# 13, but will make it into C# 14. And the reason I'm not going to spend a lot of time talking about C# 14 is that every time, if I talk about C# before it's actually released, someone tends to remove a language feature, which is super annoying. But this time, the field keyword is in there. We can turn it on, and I'm going to show you exactly what this looks like. There's also a thing called params collection. So we can now use params with collection types. There's a completely new way of locking in C# and in .NET. It's a combination of support in the runtime, the framework, and as well as the language. There's something called implicit index access. I haven't seen anyone use this in the the real world yet, so I'd be very interested to see if someone in here finds a good use case for it. There's also a thing called a overload resolution priority, partial types, and a whole lot more things. So let's jump over to Visual Studio for a final time. I have a couple of language features that I'd like to show you. That's the wrong project. Here we go. So the first one I want to talk about is implicit index access. So here I have a type called data, which simply has an array exposed on it as a property in this case here. It's already initialized, but now I'd like to create this object and say, hey, from the end, you're going to set these values. Sometimes this might be a good idea depending on what you're doing. I haven't found a good use case for it myself yet, but since you weren't able to do this before, maybe you want to reverse an array or something like that. It could be an interesting approach to do that. But yeah, you can now reference the last element, or 2 from the end, or 3 from the end. You don't even have to do all of them. It doesn't have to be the same size of that specific array. Now, in terms of locking, we should all try to avoid this normally, because locking leads to deadlocks. But if we're working in multi-threaded applications, like, we don't have an option to do that. If I change this to an object, the compiler will now work with this and see that, hey, you want to use the old style locking mechanism, which uses a monitoring API, which might not be as good for thread synchronization as it could be. So therefore, they introduced this new type in .NET called lock. Same thing, really, just used as a object when you're locking. But the behavior here, when the compiler sees this, that we're using this type, it will now use a new API instead, which is a lot more, it's better for thread synchronization, basically. So you should be able to simply change all your sync routes, or whatever you call them. Instead of using objects, use lock, and it should work. And again, just recompile the application. Yep?
Async support?
Async support? No, there's no async support. But you can use semaphore or slim, for example, if you want to do that. Yeah, I don't think you've ever been able to do locking using async. So yeah, you'd have to do another approach. Yeah. Do you have another question?
When you say it's better, do you mean it's just faster, like result in less contention?
No, it's just in terms of thread synchronization. It's I don't think it's the performance-wise. I don't think there's a difference. But I don't know. I haven't benchmarked it, so I'd have to look it up. Just thread safety, basically. But that's a good point asking about async, because that's one of the things that if you want to use locking in async, there's this class called Semaphore Slim. Don't confuse it with Semaphore. Semaphore Slim is a little bit less expensive to work with. But basically, you can do the same thing. You can say, hey, I'd like to create a lock, await that, and then run something in the lock. You can also use that for throttling, for example, in asynchronous operations. All right, so next we have this thing called params collections, which is a way for us to say, hey, I'd like to use params with a list or an enumerable or a read-only span of a character and a span and so forth. And these all then allows us to either pass them as a single element. If we were using them up here, I could either pass it in as a collection, like here, I'm creating a collection using the collection expressions, or I can pass them in as just strings. And the compiler, again, will try to use the most performant way or the best one. But sometimes it can't figure out exactly which one you're using because it's an ambiguity. In this case here, it doesn't know, in my case, depending on how you use this, it doesn't know if it should use read-only span or if it should use the list of string. So therefore, I can say which one has the higher priority. Higher means it's more important. In this case here, I'd prefer that you use read-only span of a string instead of using the list of a string, because I'd assume that if you accept a read-only span or a span, that should be more memory efficient. If you're building APIs, either internally or something on like an open source project, this is a really great addition as well. All right, finally, there's going to be two things I'd like to show you. There's going to be partial improvements. You can do partial properties. And in C#14, you're going to be able to do partial more stuff. It's good for source generation, so I'm not going to spend more time talking about this. You wouldn't write your own partial stuff like this here, like it's only for source generation. What I do want to show you is this very interesting language feature. And to turn this on, sorry, I'm jumping around here, but you have to say lang version preview. And again, if you go back to an older version of .NET and working, for example, in .NET Framework 2.0 or whatever, you can change the language version and set whatever you want here. And the compiler for that, if you use a later version of Visual Studio, will then allow you to use newer language features as long as you stay away from things that require new types in .NET and stay away from things that actually doesn't have compatible IL. There's ways around that as well, but yeah, send me an email and I'll show you. So what I want to show you, let's go back here. So I have set the preview version, language preview version, right? This gives me access to this new field keyword. The field keyword allows me to reference the backing field of an auto property. So just ignore that I have a private string field there at the top that's commented. What happens here is that when I access field, this publicly exposed property, doesn't have to be, could be called whatever, right? It's kind of confusing that I named it field now that I think about it. The keyword, it's a contextual keyword, so it allows us to reference whatever backing field this auto property has, because all auto properties, they have a field associated with them in the background, right? But you've never been able to access that before. So now we can either do it when we are retrieving that element, say like, hey, I'd like to change this some way. You can also do it in the setter if you'd like to. Personally, I like to store data in the way they get added to something and then modify it when I actually retrieve it. Because I've cleaned up data way too many times before I save it, and I've done it incorrectly. And then you have dirty data, which is not good. So then, I guess what happens, and that's the reason for my little comment up here, what happens if we already have a private field that's called field? Like normally, this would then access this field, right? However, because this is a contextual keyword, it has meaning inside this here. It's just like using the async and await keywords. If you have a variable called await, how would you access that? Well, you'd have to use this syntax to say, I'd like to actually access my backing field called field. Now, if you're working with teachers, for example, they have a field that they're working in. So, I mean, it's not totally uncommon that you might have data with these variable names. But the reason, I guess, this is now a preview feature is because just updating to the latest version of .NET and recompiling your application would have had a really huge breaking change. Because all of a sudden, if you were referencing field in your class, that would have no meaning anymore. And this might be modified from somewhere else, right? And all of a sudden, just by updating to .NET 9 and recompiling, you broke your entire application, which I guess is contradicting what I said earlier, that you should always update. You should update and test your applications. So that's why it's a preview feature, and it's going to be available in C# 14. Hopefully, there's going to be some analyzers telling you, there already is an analyzer.
That warning should come up even if you're not using preview blanket.
Oh, perfect. So this warning shows up.
Warning. You opt in if you want to blanket.
Ah, that's good. So this warning will always show up. It didn't actually the last time I did this. I don't think I had this warning. So this must be new. That's actually very good. This brings me to another suggestion. Actually, go into your CS prod file, and there's this other amazing feature that you can say, treat warnings as errors. True. There we go. And recompile the application. I believe it's true. Some of them are true, false, on, off, disabled, enabled. Why stay consistent? So now I can't even recompile the application anymore. Now, I joke that people should turn this feature on and just go on holiday and let someone else fix the problems. It's probably also a good way to not be allowed back from your holiday. But yeah, then in this case, we'd get that warning right out of the box. Like, if you're updating to a new version of .NET and you don't have any warnings, how about turn on treat warnings as errors? And then you'll figure out that, hey, I had an issue here, which is probably something that we have to fix. So with that being said, I think that the field keyword is probably, here's another example of it, but this is probably the first language feature that introduces a breaking change in this manner. I can't remember that I've seen any other language feature that would break your code by just recompiling the application. So again, to get rid of that, we'll have to use the keyword escaping, just the @ symbol there in front of field in this case here. And params collections is a great way for us to now also allow params with enumerables and spans, and this builds on the concept of a collection expression. And it will attempt to use the one that's most appropriate. It will favor span over array, for example, and it will use a value parameter for implicit conversions, and it's trying to be clever. In this case here, as I mentioned earlier, if I have a passing in my names using a comma like that, or using a collection expression like I'm doing at the bottom, these two are ambiguous. And that's why we want to introduce that attribute called overload resolution priority, which sets that higher priority for the most important one. All right. So I guess with 2.5 minutes left, what's next for C#? There's potentially going to be partial events and partial constructors. There's dictionary expressions. There's extensions, everything. So you could pretty much say, like, hey, I'd like to extend this type with more properties. You can do a whole lot of interesting things. But also, there's this work on improving async called runtime async or async 2 or whatever the name this week is. It's meant to change so that instead of doing compiler magic to create the state machine and to do all of that which is necessary for async and await to work, how about if the runtime knows about the concept of async? How about it knows about green threads and be more performant? Because honestly, like, sure, the state machines and the implementation of that is super good. It's very performant. But if the runtime knows about the concept of async and can be much better at switching threads and do that very efficiently, that would be a better approach. So I doubt that we're going to see this in .NET 10. But also, that gives me a reason to come back in 5 years. We'll see when that gets here. But a cool feature to keep an eye out for is extensions everything. And the reason I don't show this is it's because it's probably going to change by the time it's released in November. So we've talked about all of the interesting features of C# and .NET. And I mean, if you like listening to me, I have 25 plus courses on Pluralsight covering all the language features of C# and asynchronous programming, and actually released a course on how to build operating systems, which I don't think anyone does anymore, but it's still. I had to read up on kernel development, C and C++. But if you like this, and I hope you're encouraged to take a look at what's new in C# and what's new in .NET, and go ahead and try to update. Don't be scared of the version that's released every November. At least attempt to update or convince your boss or your tech lead or architect or whoever decides who gets to update. Try to tell them that, hey, Filip told me that it's fine to update. And when it doesn't work, you just call me and I'll help out. I'm kidding. Again, if you have any questions, just send me an email. It was a pleasure talking to you all. Thank you so much for all the good questions. And again, I hope you liked all the stuff that's new in .NET and C#. And on your way out, you can leave a little green thing in the box. If you didn't like it, you can just skip to the beers. All right. Thank you so much.